Alrighty, this video is going to be on solving equations that have a radical or a square root symbol in the original problem, and finding out how you can get an answer from those type of equations, and then checking and verifying to make sure your answer is a possible solution. There's a little bit of a trick to make sure that you don't have an answer that's not a solution. So, solving equations with square roots. So, previously we've learned about solving equations with something squared, and we learned that the way to solve those was you had to undo the squared operation by taking the square root. And we did that. When we did that, we had to branch, which gave us two possible answers, but everything else about the problem was the same as normal. We branched and then we solved by undoing the PEMDAS, going backwards to get x by itself. So this is going to be very similar, solving equations with the square root of stuff. Instead of taking the square root to do the opposite of squaring, we're going to end up squaring the equation, which is the opposite of square, so kind of the inverse of it. But before we take the square of both sides, we need to get the stuff that's in the radical by itself. So similar to before, you don't want to branch until the absolute value part or the square part is by itself. Here, we don't want to square both sides until the square root symbol is by itself. And just a reminder, when you square a number, it always comes out positive, and there's only one answer. So you do not need to branch in these problems. Even though you're dealing with squares and square roots, you will not branch. And then final note to yourself, once you think you have the answer, you have to plug it back in and make sure it works, because there's a chance that you could have a square root of a negative in your problem, and then you'd have no solution. Alright, here we go. A couple of examples to just kind of flesh this out. We want to find the value of x that makes this equation true. In order to do that, we have to get rid of this square root symbol. In order to do that, we're going to have to square both sides, but we don't want to square both sides until we have this by itself. You can easily see why, because think about this. Can I do this? No. If we were to square this entire thing right here, it would be a polynomial squared, and we just finished learning that you can't distribute the exponent to a polynomial squared. It would cause all kinds of trouble for us. So first let's subtract the 5. You'll see this makes it way easier. We have the square root of 2x minus 3 equals 8 minus 5 is 3. Now the radical is by itself. So if we square this side and we square this side, it's super easy. The square root and the squared are the opposite of each other. They cancel out, leaving behind just 2x minus 3 on this side of the equation. And on this side we have 3 squared, which is just 9. Again, remember, no branching. And from here we solve like normal, very easy. Plus 3 on both sides. Cancel those out. 2x equals 12. If you divide both sides by 2, you can see you get x equals 6. So this seems like it's a pretty simple, easy way to do this, maybe even easier than the other way because there's no branching. But now let's make sure it works. Let's check our answer. So to check our answer, we're going to plug 6 back in the original problem. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3, and 3 plus 5 is 8. So it works. You just have to be careful, because sometimes when you plug it back in, you end up with a negative under the square root, which is the sure sign that your answer is not actually a good solution. Let's do one more example. Okay, try to solve for x here. Again, we want to take this squared part and get it completely by itself. So we're going to have to undo this negative 5, and we're going to have to undo this times 3. 3 times the radical. So first thing to undo is the 5. And we add 5 on this side. So now we have 3 times the radical equals 6. Inside we had the 8 minus x. To get the radical by itself, we need to divide both sides by 3. Cancel there. So we have the square root of 8 minus x. We've gotten the square root part completely isolated by itself. On the right hand side we have a 2. So now we're ready to take the square of both sides. We're squaring both sides of the equation. The square and the square root cancel out, leaving behind whatever was inside, 8 minus x. And that's going to equal 2 squared is 4. Alright, subtract 8 from both sides. We get negative x. Very careful that you keep the negative sign with the x. 4 minus 8 is negative 4. And so the final answer is x equals 4. Just multiply both sides by negative 1. So final answer, x equals 4. Again, let's plug it back in, make sure it works. If we plug the 4 in right here, we get 8 minus 4 is 4. The square root of 4 is 2. 2 times 3 is 6, and 6 minus 5 equals 1. So it works. It's unfortunate I didn't have an example here that doesn't work. Let me make up one real quick just to show you. You might have the square root of x plus 1 minus 3 equals negative 7, something like that. So say you were to solve this kind of problem, you go plus 3, those cancel, and you get your square root of x plus 1 equals negative 4. You could keep going because you could square both sides, right? And you'll get a number over here, but it's very clear that the square root will never be a negative 4, so you can see right away here there's no solution. But even if you didn't realize that, right, if you hadn't realized that, and you try to square both sides, square here, you're going to get x plus 1 on this side, because the square and the square root cancel, and negative 4 squared is 16. And then when you subtract 1 and you subtract 1, you obtain an answer of x equals 15. And when you plug this back in, you can see right away 15 plus 1 is 16, and the square root is 4, not negative 4. There's some other cases, so always make sure you plug your answer back in and make sure it works. When you're trying the sample problems, see if you run into any that, when plugged back in, they give you the square root of a negative. That's certainly a possibility that you want to avoid. Alrighty, good luck.